right now.
All right. Thanks, Sarah. So, hi, everybody. I am Jill Schultz, Ontario County Master Gardener since 2019. And I want to thank you also for coming tonight, joining me tonight for this presentation called Beyond Honeybees, the Role of Wild and Native Bees as Pollinators. I have a lot that I'm going to try to cover. I think I might have been a little bit overly ambitious. So that's why Sarah asked if everyone would hold their questions till the end or make comments in the chat, questions in the chat, and we can take a look at them when we're done. I'd also like to say that although I've attended way too many Zoom meetings over the past 3 years, first time I presented,
Your audio's skipping out, unfortunately, Joe. Can you hear me? Yeah, you might want to turn off your video, Jill, just so that we can hear you, because right now it's not coming through. And I'm not sure if everyone else can maybe assist with that. I'm not sure if it helps, but if you don't mind turning off your videos, that would be super helpful.
Know where I kind of cut out, but I was saying this is my first Zoom presentation, so bear with me. I don't know if everybody heard that or not. So we're going to start with a brief general overview of bees before talking about how honeybees became so popular and all the attention that began after colony collapse disorder. And then we'll follow that attention as it moved away from honeybees to the plight of all pollinators, the importance of pollinators, and the current issues that impact their health and survival. We'll specifically explore the role of some of the wild and native bees, looking at some of the cavity and ground nesting bees that we might find in our own backyards. And then we'll end by talking about attracting those bees and other pollinators to the garden. And I want to take a quick moment and say that any of the pictures in this presentation that do not have credits listed were either taken by myself or by my neighbor, Bob Minkley. Lucky for me, Bob is an entomology professor at the University of Rochester, specializing in solitary bees. And he was kind enough to share these photos, some of these photos from a presentation that he did. And he also very patiently answers any number of questions that I throw at him when I have a bug in my yard that I can't identify. Are we getting a little feedback?
Someone was had an unmute, so they are muted now.
We're good. Okay. Yep. All right, great. So bees are a species-rich group. If we do a comparison to other groups, we see that bees have approximately the same number of species as fishes. There's more species of bees than birds and reptiles combined. There are as many species of bees as birds, mammals, and amphibians combined. And if you add wasps in there, there are more species of bees and wasps combined than plants. So what does this diversity look like in terms of numbers? Well, depending on the source, worldwide, about 20,000 different bee species. In the North America, about 3,600. And in New York State, depending again on the source you look at, around 450 bee species. And this includes native and non-native wild bees. Like, for instance, the wool carder bee, which is a wild bee, but not native. And then, of course, there's also wild colonies of honeybees, which also are not native. So bees are insects from the order Hymenoptera, which includes the wasps, ants, and sawflies. They evolved from predatory wasps. So bees and wasps, as we probably all know, can be quite similar in both appearance and behavior. And while there are both social and solitary species, the majority of bees are solitary. And as we'll also see, there's quite a bit of variation, including in size. And just to highlight that a little bit, Here's one of the largest and the smallest kinds of bees found in North America. That's a carpenter bee sitting on top of a quarter on the right, and a perdita, which is found in the desert regions of the United States. Physical characteristics can also help us to distinguish bees from wasps. If we look at this photo, the top 3 that we see are wasps, the bottom 2 are bees, and we notice the difference in body shape. There's more hair on bees, there's pollen collecting hair on bees, which we don't see on the wasps. They're usually more thick-bodied than the wasp. And we also can use behavioral differences to distinguish bees from wasps. So both bees and wasps, they visit flowers for nectar, but bees spend more time on flowers because they are collecting that pollen for their larvae rather than insect prey like the wasp would. So if you see a busy creature flying from flower to flower and you're not sure what it is, it's likely a bee. And of course, for every rule, there's at least one exception. The trigona on the left is a type of stingless bee that carries the nickname vulture bee because it scavenges on the flesh of dead animals. And the Pseudomosaurus wasp on the right, just like bees, feeds its young with pollen. In addition, certain bees don't have much hair on their bodies because they collect pollen and store it internally. So sometimes it can be difficult to tell the bees and the wasps apart. Another commonality is that almost all bees, except of course the stingless bees and wasps, can sting multiple times. It's only the honeybee that dies after the first sting. And because that stinger is actually a modified egg-laying apparatus, it's only the females that can sting. In terms of social structure, bees fall into 3 kind of overarching categories, and there's some crossover. The percent of distribution varies a bit depending on what source you look at. So the kleptoparasitic bees, they got their name because their behavior is reminiscent of the behavior of cuckoo birds. So while the solitary and the social bees, they work hard to make a nest and find food, the cuckoo bees enter the nest of other bees. They lay their eggs, and when they hatch, the larvae kills the host egg and consumes all the pollen and nectar. And because these bees have lost those morphological structures for nest construction and pollen collection, they do look more wasp-like with an elongated jaw for puncturing eggs and larvae. And so you can see here, this cuckoo bee is using that jaw to lock onto a branch and get some sleep. They don't make nests, so they don't have a home to go home to. The majority of bees are solitary, accounting for more than 3/4 of bees on Earth. They include the above ground cavity nesters like the mason and the leafcutter bees, but the majority are ground nesting, otherwise known as the digger bees. And oops, let me go back. No, I was right. There we go. Okay. So eusociality is considered an extreme form of social behavior found in just a few types of animals, and this would include some bees, like the honeybees, the bumblebee, and the stingless bees, which are mainly tropical and subtropical. These are social nests characterized by the presence of several generations at the same time, cooperation by some members of the society in caring for offspring, and a division of labor with queens that reproduce a lot and workers that reproduce very little, if at all. The picture over here on the left is a picture taken in Costa Rica of a nest of a stingless bee. The guide called this a mariola, and the bees would enter and exit through this flexible tube. This is another picture and on the same trip of a different nest, and this was actually on the side of a building. This is a step going up into what was a public restroom, actually, and you can see the little faces peeking out. So this brings us arguably to the most famous of the eusocial bees, the European or Western honeybee, introduced into this country about 400 years ago. And this is a great shot of one of the worker bees with her pollen baskets full and neatly packed. And I'd like us to keep that picture in mind because we'll visit it again later on the talk. And although wild colonies do exist, as I said earlier, it's considered a managed pollinator. And so here's a photo of a typical managed bee yard, maybe a sideline beekeeper, not be a hobbyist, but I think almost everyone is familiar with the term colony collapse disorder. This was back around 17, 18 years ago during the winter of 2006, 2007. And beekeepers noticed really unusually high losses, 30 to 90% sometimes of their hives. These huge losses were just inconsistent with any known cause of honeybee death up until that point. There was a sudden loss of the colony's worker bees, with very few dead bees found near the hive. And the queen and the brood remained, and the colonies had relatively abundant honey and pollen reserves, so we knew that they weren't starving. It really left beekeepers scratching their heads about the cause. It garnered a lot of attention, both from scientists as well as the general public, which is why today, when you say colony collapse disorder, most people have a sense we're talking about honeybees, even if they don't know the details. This led to closer monitoring of colony losses as beekeepers and researchers tried to figure out what was going on. This slide shows data from the US Department of Agriculture looking at the number of honey producing hives in the US from producers with 5 colonies or more, from 1945 on the left until 2007 when CCD was first occurred or was first reported. In 1950, we see almost 6 million honey producing hives in the US. And then each year there's somewhat of a decline until we get to the late 80s when we see a bigger dip. And then finally to 2007 when we're down to less than 3 million hives, so almost half of what we had in the 1950s. That dip in the 80s, it seemed to correspond with the introduction of tracheal and varroa mites, and researchers believe that this has a role to play in CCD, and it's still a big problem for honeybees and therefore for beekeepers. And in fact, if you talk to quote unquote an old time beekeeper, they talk about the golden years of beekeeping back prior to the 1980s and how much easier it was then, in part because they didn't have to contend with these pests and the diseases that they cause. Bee Informed Partnership, which is a not-for-profit affiliated with the University of Maryland, started keeping data about 16 years ago when CCD was first recognized. And this graph illustrates colony loss from 2006, 2007 to 2016. The light tan bar, the lowest bar here, indicates acceptable winter loss, which they consider to be somewhere around 20%. The yellow bar indicates winter loss, and then this orange bar indicates annual loss. And we can see from their data that winter losses from 2006 to 2016 averaged around 30%. Annual losses were in the range of 40 to 45%. I checked recently, checked their website, and in 2021, we saw the highest annual loss since the inception of the survey. It was up at around 50.8%. The numbers for 21-22, this past winter survey, isn't complete, but it stands at about 25% winter loss and 40% annual loss. And this survey for this year and every year it goes out in April. So we see a really significant loss of the European honeybee over a relatively short period of time. And the decline continues with subtle variation from year to year. Researchers haven't been able to pinpoint one specific cause for CCD, and most sources now agree that its causes are multifactorial. So it's often talked about in terms of multiple stressors. And this would include monoculture crops and habitat loss, transnational transportation, pesticides, varroa mites and other pests, and climate change. And so these reports about colony collapse disorder started surfacing. And as they did, the media really took off with this. And we became actually kind of inundated and alarmed by articles about the vanishing honeybees. And these are just a few of the highlights. We had some straightforward articles and some more whimsical articles, some pretty dramatic headlines. And then the most alarming to me was the disappearance of ice cream. And, you know, I'm making light of some of these headlines. I understand the media has a job to do, and they did it really well. We became aware of the disappearance of honeybees, but perhaps became a little overly focused on that one species. The very real message in all of this was that not just honeybees, but pollinators in general were struggling. And yet, in general, people became increasingly and rightly concerned, but almost obsessed with the honeybees, including me. And this is not me. I have yet to try that. But I became alarmed about what was happening to the honeybee, and my interest grew, and I started reading more about beekeeping. I started attending a local beekeeping club. And then finally in 2015, I bought my first hive. I picked them up on a sunny day in May, and these are what they call package bees. They were driven up from Georgia, and I brought them home, I put them in a hive, and because I'm a gardener, I put them next to my pollinator garden. You can see the hive in the back there as it grew. And it did grow, and it grew, and it grew. They multiplied, and I got stung and got stung again and stung again. I ended up with some delicious honey. It was a lot of fun, and I learned a lot. I really learned a lot, but I couldn't beat the statistics. And although I managed to get, I managed to get my hive through the winter. Unfortunately, as you might expect from the number of annual losses that I quoted earlier, eventually I lost my bees, and I bought more, and I lost those bees too. So after 3 years, my experience ended kind of badly with dead bees and some significant reactions to bee stings. I have a small city lot, which is not the best place to start a bee yard. But as I said, I learned a lot, and it really got me thinking about bees and other pollinators. So as my own lens broadened, and we began to see different kinds of articles appearing in the popular press, as well as in academic literature, talking about honeybees in a very different way. So instead of a honeybee obsession, we had kind of a honeybee backlash as the attention on the plight of the honeybee began to spill over into concern about pollinators in general. And these are some of the headlines from 2017, 2018, and 2019. And this is a quote from the journal Cell from 2011. It says this assertion that honeybees are essential pollinators for the maintenance of natural biodiversity and agriculture has a substantial history and appears to be lodged in both the academic and the public consciousness, but in fact lacks empirical support. This one a little more close to home. This is from Brian Danforth, a Cornell entomologist, says the role of native bees in crop pollination has been largely unappreciated until colony collapse disorder created a crisis. And this one up here from an article in Science in 2015, honeybees will be fine. They are globally distributed, domesticated animal. Apis mellifera will not go extinct, and the species is not remotely threatened with extinction. Whoops. And this quote from New York Fruit Quarterly in 2015, again from Brian Danforth: non-native bee species can have a negative impact on native species for a variety of reasons. Non-native species may compete with native species for floral and nesting resources. They may carry pathogens that can infect native species, and they can cause mating disruption when they are closely related to native species. Unfortunately, we know very little about the impact of non-native bees on native Eastern North American bees. And this was not just a North American concern. In 2021, alarmed that the number of beehives in London more than doubled over a 10-year period, the London Beekeepers Association issued this statement: the prevailing Save the Bees narrative is often based on poor, misleading, or absent information about bees and their needs. It can imply that keeping honeybees will help bees, which is not necessarily the case. And Kew Gardens, in its State of the World's Plant and Fungi report, issued this pointed statement: campaigns encouraging people to save the bees have resulted in an unsustainable proliferation in urban beekeeping. And this approach only saves one species of bee, the honeybee, with no regard for how honeybees interact with other native species. So, from the honeybee as hero to the honeybee as pretty much villain, perhaps what is most valuable of all is the attention that was brought to the plight of the pollinators in general. This was not exactly a new concept. This book came out in the late 1990s, long before CCD. The authors asked us to take a closer look at the role of pollinators in our food production, and also the underappreciated relationship between native plants and native pollinators. It highlighted the problem of relying solely on one species and why biodiversity is important. So now that we've taken a little journey from an overview of bees to why and how so much attention was brought to the honeybee and how that helped bring attention to the plight of all pollinators in general, let's spend the rest of our time looking at native and wild bees. And to do that, I'm going to ask you to take one last look at the honeybee. Earlier, I shared this picture, and as we move into talking about wild and native bees, let's just revisit it for a moment and take notice again of those really tightly packed pollen baskets on either side of her abdomen. And then let's compare that with a picture of a wild bee. I apologize, this is a pic from one of my neighbor's pictures that he shared with me, and I don't have the name of this particular bee. It is a native bee, but notice how messy it is. And this messiness is, in fact, one of the reasons why native and wild bees might actually be better pollinators than the honeybee. In fact, native bees are berries, strawberries, eggplant, squash, really regardless of their put pollination and natural world is bees. Indeed, wild rely on relationships they forged with wild native bees over millions of years. So again, here in New York, there are approximately 450 bee species in the stuff of non-native species. For our purposes, going to break this down into two nesting categories as a way to talk about them further. And talk about the ground nesting bees and the cavity nesting bees. So the ground nesting, these are the cellophane bees, mining bees, squash bees, longhorn bees, sweat bees. These are the bees that are active in early spring. In fact, we'll start seeing them soon. And you tend to find them in areas on sunny slopes. You tend to see them, a lot of them together. And if you take a walk through Highland Park in Rochester in a couple of weeks, you will see them by the thousands. Despite what many people think, they're pretty docile and you really don't have to worry about getting stung unless, of course, you try to handle them, I guess. This is a picture taken on April 7th of last year, 2022, at Highland Park. This was a really sunny south-facing slope, and you can see this little face peeking out. If I had a wider angle, you would have seen thousands of these little tiny nests. So at the start of the nesting season, the females begin constructing these burrows in the soil, which they line with waterproof secretions from specialized glands. They sculpt a ball of pollen and nectar, and they lay an egg on top of it. And then they close the brood cell and construct another one. So a typical solitary female might produce just 10 to 15 offspring over a period of 2 to 3 weeks of active foraging. And they forage quite close to the nest, generally within about 3/4 of a mile. And they can be seen on the spring blooming trees like maples and apples, eastern redbud, serviceberry. And they can also be seen on the garden bulbs that are flowering now and will be flowering for the next couple weeks, like snowdrops and willows. So next are the stem nesters, such as mason bees, leaf cutters, resin bees, carpenter, wood carder, just to name a few. And these are the bees that build their nests in hollow tunnels or rotting logs, or like the carpenter bee, they may just excavate your picnic table or some other piece of wood that you wouldn't want them in. So I want to spend a few minutes about two cavity nests that are of particular interest to gardeners, and these are the leaf cutter and the mason bee. Leaf cutters are about the same size as a honeybee, but they look different. You can see from these pictures that they carry and collect their pollen on their abdomen. So that's one way you can tell them from other bees and from the honeybee. They use a variety of twigs, box elder, elderberry, various caneberries, roses, to construct their nests. And they prefer certain types of vegetation to line their nest cells, notably rose, green ash, lilac, and Virginia creeper. Last year, I noticed that some of the red buds in my yard had nice little circular bites taken out of them. And like the ground nesters, they provision each of those cells with a mixture of nectar and pollen. So this is a finished nest tunnel. It may contain a dozen or more cells, forming a tube from 4 to 8 inches long. And the adult females may live up to 2 months and lay 5 during this time. The young bees develop and emerge the next season. And sometimes they use flower petals, which lead to these nest like works of art. Another example of different material they use. So the mason bees, their name stems from their practice of transporting mud to the nesting areas to build structures in which they eventually lay their eggs. Picture of a bee house that I have hanging on a fence in my backyard. So they will construct individual nests in hollow reeds or plant stems or pre-existing bee hotels, and pollen and nectar, and seal off the cell within mud. After the temperature reaches 55 degrees warmer, both the male and the females will emerge. And this is a close-up of what those kind of structures and be constructed a nest. So in the spring, they'll begin chewing their way out of the nest. Male bees come first and remain close to the nest. Then the females hatch. They're unable to fly. They immediately mate with the waiting male bees. So bee hotels can be installed in your backyard, especially near the garden, since they don't go far. You want to face the bee hotel south or southeast, so it warms up in the morning sun. And species, who use these hotels are considered solitary, so they're less aggressive, even less likely to sting you than bee. I'm going to try to play this video. We'll see how it goes. This is a new emerged in April 22nd, 2022. I had watched the Hive for a while and managed to catch that one. And this is a great side-by-side comparison of a leaf cutter and a mason bee nesting cavity. So you can really see how the mason bee mud to construct its cells and how the leaf cutter is using the leaf. So the same conditions that threaten the honeybee threaten the wild native bees as well, except transnational transportation. We looked at this earlier, but it's helpful to revisit as we transition to talking about what we can do as gardeners and property owners to help pollinators. So the single greatest impact and fragmentation in agriculture, which all impacts the nesting levels of parasitic and predator populations, and the genetic structure of bee populations. In your own backyard, to encourage pollinators to visit our gardens and our yards, we can provide habitat, provide and we provide plant. We can change our cultural practices and eliminate pesticide use with native plants. We can reduce or even replace our lawns, even an infrequently used portion of your lawn. So this is my garden, and and in the spring, depending on where you live, you can wait to clean up. Don't clean up your garden till providing habitat for bumblebees. This is a pile in my in my yard of logs and rocks to provide some overwintering habitat and nesting. The message is that bees like messy gardens and yards best, and this photo might not be what a lot of gardeners are going for, but I think that's what bees are going for. So we want this, even though this isn't a garden, it's a nice picture and it's some great goldenrod, not this. So what can we do specifically for the ground nesters? Wherever possible, avoid turning over the soil, leave some bare, uncompacted soil, clear some vegetation from sunny areas, use other different types of ground conditions or provide other different types of ground conditions to draw different bee species. For the cavity nesters, we can leave some shoots, some stems, some rotting wood. We can make those bee hotels. Again, install one, especially near the garden, since they don't travel far. You can really hang it anywhere. They say hang it at least 6 feet, hang it in the sun on a southern exposure. They seem to work anywhere. This is actually a picture of kind of one of those metal sculptures that you hang on the back. This is hung on the back of my house on northern exposure. And all of these little branches are hollow tubes. And come to find out, I came out last year. I hope you can see that, to see that they have been um, taken over. There's nests in those hollow tubes now. So the bee hotels don't have to be fancy. You can do a DIY bee hotel. These are actually saved from the middle of dog poop bags. So people out there who are listening that own dogs, do you know what I'm talking about? It's when you get to the last dog bag, that's what's in the middle. You can save those up. You can turn a pot on its side, and there you go. There's all kinds of different bee hotels you can purchase, you can make. They look like works of art. And you can even buy your mason bees or your leafcutter bees. So I could do a whole presentation on this alone, and there are many good presentations out there. There's a lot of good information out there. And it comes back to basically planting natives, planting in groups to increase pollinator efficiency, planting with the season in mind, providing food from early spring to late fall, diversity, planting flowers of different color, fragrance, heights. They'll attract different pollinator species and provide pollen and nectar throughout the season. It's just a very short list of perennials. These are common names, so my make sure it's a native, probably not a car. This is an exhaustive list. Didyma. This is bee balm in my yard, the red variety. This is it here. So try to play a short video again. It attracts a lot of bees. And it also, I hope you can see that hummingbird. It'll back up in a minute. It attracts a lot of hummingbirds, and one was just resting. Swamp milkweed. Again, there's a hummer hanging out. Despite its name, swamp milkweed seems to do better in drier soils than the common milkweed that you see along the side of the road, but it sure spreads. So yeah, if anybody wants swamp milkweed, I have a lot, let me know. Annuals, if you have one of these in your garden, you might not see too many hummingbirds. These are some of the annuals you can plant. And trees and shrubs. This is a picture taken at Highland Park. Although it was taken last year, it's the same year. The witch hazels are blooming there now, and on a warm, sunny day, it's covered with bees, absolutely covered with bees. As we wrap up, I just want to say that, of course, it's bigger than bees. It's really beyond honeybees. And we should of unsung heroes of pollination. And just a couple unusual animal pollinators that we usually don't hear about. The lemur is the world's largest pollinator. There's the honey possum on the left, and even reptiles. This skink is found in Brazil. It drinks the lemur actually pries open its flowers and puts its snout in to get the pollen out. Kind of cute. So there's an exhaustive number of resources out there. These are some of the resources that I use and just to learn more myself. These are some of the resources that I use for this presentation. And this on the left, this Western New York guide to native plants for your garden, is put out by the Buffalo Waterkeeper. If you go to their website, I'm pretty sure you can still download that as a PDF. It's a great resource. On the bottom left here is selecting plants for pollinators. This is a regional guide from the Pollinator Partnership. If you go to that website and put in your zip code, you can download the PDF for your area. Some of you might be familiar with the Plantsman Nursery, which is opening, I think, next week. And of course, Amanda's Garden. It's amazing the number of native species that they have in Dansville. Books. This is the book that I mentioned, Bob Minkley and Brian Danforth and John Honeybees. They're here, The World of Bees, Bees in Your Backyard. And then this book on the right, Planting in the Post-Wild World. This came out in 2015. 2015. They focus on planting for diversity and ecological function. So they're moving beyond the native versus exotics debate. It's a really interesting book. And they state, quote, will grow in the future, especially as things are changing. It's out. And with that, I think I did it. I got through it all. Thank you so much. And if there's questions, comments, feedback, I'd love to hear it now. You can feel free to email me, especially if you want some swamp milkweed, please. Take it. It's yours.